Okay, this video is going to give you a kind of a summary and tutorial over 7-7 for natural logs. But first, we're going to review a little bit over 7-6. If you're asked to express log base 4 of 2.2 to the third as a common log, then what we learned was we would take the log, the common log of 2.2 to the third, and common log is base 10, divided by log base 10, which we usually don't write the 10, of 4. And then we can put that in our calculator. Now it might be easier if you're putting it in the calculator to move the 3 as a coefficient, but you don't have to. You can put it into the calculator, but as it is, but you need to put the 2.2 to the third in parentheses before you divide by log base 10 of 4. And the log button on your calculator doesn't show base 10, but it is base 10. And so you get 1.7063. Now, on a problem like this, we're not asked to put it into the calculator, but we're just asked to set it up and see what it would look like solve for x without putting it in the calculator. So 9 to the 2x power equal to 45. If we have a variable in our exponent, then we can take the common log of both sides. So that would be the log of 9 to the 2x power equal to the log of 45. We can move the 2x. We should move the 2x out and as a coefficient. So we get 2x times log of 9 equal to log of 45. Divide both sides by log of 9. We get 2x equal to log of 45 divided by log of 9. And then we would want to divide both sides by 2. Or, in this case, if you don't want to divide a fraction by a number, then you could multiply by a half, which is doing the same thing. But maybe that'll help you figure out which of these answers it would be. So the 2 is in the denominator, and that would simplify since that canceled out. X would be log of 45 over 2 log of 9, which would be B. Okay. So we're going to work with what's called natural logs. So we worked in base 4, we've worked in base 10, we've had all types of log with different bases. E is a number. It's not a variable that's going to change in value with different things. For example, x might be 2 in one problem, and in the next problem it might be 5 or negative 8. E is similar to pi. Pi always has the same value, 3.1415927, whatever. The square root of 2 also has a value, but it's a decimal that, a non-repeating, non-terminating decimal. E is also a number, and it's a number that won't change in value over time. On your calculator, you see a button that has E. On your calculator, the divide sign has a little bitty cursive E on it. On your calculator, it'll probably be yellow. So if you hit second divide, you'll see the letter E. Now, if you hit enter, that is the value of E, 2.7182818828. And this number, where it comes from is hard to explain, but it's used for calculating continuous growth and continuous decay. But what you need to understand that it's just a number. And so we might have log of base 10, log of base whatever, log of base 2, but we can also have log of base E. So E is always equal to 2.71828188, and it keeps going. But we don't want to write log of base 2.7182818828. We don't want to write that. So instead, we just simply use the letter E as our base. But we can't change the base on our calculator, but this natural log of base E is used so much that the calculator has something else for it, ln, which stands for taking the natural log of whatever you're using. ln is right below the log button. So that would take the natural log of some number. Now, if you took the natural log of E, just like if you took the common log of 10, if you had the common log base 10 of 10, you would get 1. Why? Well, let's say we didn't know what it was. Some number x. Well, that means 10 to the x power is equal to 10. Well, that means x would have to be 1. So the whole value of base 10 to the 10th is 1. Same thing goes with natural log. If you had natural log or base E of E, you should get 1. And ln is equal to natural log. So if you did ln of E, that's equivalent to, that means the same thing as saying log base E of E. Natural log of E, you also get 1. So where do we use this? Well, it works the same way as base 10, except you have to use the letter E instead of the number 10. So you use the same thing, you go about it the same way that we did when you were using base 10, which is common law. Now this is all the fine print, the messy stuff that goes along with it, but it's used for continuous exponential growth or continuous exponential decay. It's called a natural log. So, the same way that we did before, if we were going to write E, which is actually a number, to the x power equals 23, then that would translate to log base E of 23 equal to x. Base, answer, exponent. Okay? So, but log base E on our calculator is just ln. So we would put ln of 23. We can't put log base e of 23 in our calculator, but we can put ln 23 in our calculator. Okay, all they wanted you to do in this one was change it from exponential to a log function, exponential form to log form. Now in this next step, what we're going to do is we're going to change it an equivalent log for e to the fourth of x. So same thing, e to the fourth equal to x means log base e of x is equal to 4, or ln of x, natural log of x, is equal to 4. So here, e to the x equals 15. This is our base, so that means log base e of 15 is equal to x. And we don't write it like that, we write it like that. But that means the same thing. Same thing here, e to the fourth equal to x. Well, we already did that one a minute ago, right? Log base e of x equal to 4, which is ln of x is equal to 4. Natural log of x is equal to 4. So if we wanted to write this in exponential form, just pretend that's an equal sign. Natural log of x equal to that number can be written as log base e of x equal to that number, and that would be translated as base, exponent, answer. E to the 1.2528 equal to x. We can actually put that in the calculator, but they don't ask us to do that. Same thing here. Now, natural log of 25 equal to x, that means log base e of 25 equal to x. That means e to the x equals 25, or 25 equals e to the x, approximately. So again, natural log of x is equal to 1.5763. That's the same thing as saying log base e of x equals to 1.5763, which would be translated as e to the 1.5763 is equal to x. Do this one on your own. Now, how are we going to write that as a single log? Well, 4 times natural log of 3 plus the natural log of 6 is the same as, we take this 4 and move it into the exponent on that 3, we get that. 3 to the 4th, natural log of 3 to the 4th plus the natural log of 6. Those are the properties we had in 7-5, I believe. And then the rule says if you have a double log through addition, then you can change that to a single log of multiplication. Well, 3 to the 4th times 6 in your calculator is 486. And then we can actually put that in the calculator if we wanted to get down to a decimal. Same thing here. We would would take the 2, move it as an exponent. So we have the natural log of 3 squared plus the natural log of 4 plus the natural log of y. 3 things added together would be 1 natural log with the numbers multiplied together. So you get the natural log of 9 times 4 times y, 36y. Okay, so same thing here, same process. Take 4, move it over here, over to the 2, so we get natural log of 2 to the 4th plus natural log of 3, which would be the natural log of 2 to the 4th times 3, which would be the natural log of 2 to the 4th, okay, 16 times 3, which is 48. What about this one? We have a fraction trying to scare you. That is the exponent. So we'll get the natural log of 3 to the 3rd plus the natural log of 1/3. I'm going to just get see if this will help. 1/3 is the same as 3 to the negative 1 plus the natural log of x. So again, we would multiply as a single log 3 to the 3rd times 3 to the negative 1 plus times x. Well, the rule here is when you have like bases multiply together, you would add the exponents together. 3 plus negative 1 is 2, so we end up getting 3 squared times x, which is just 9. So we get the natural log of 9x. How are we going to solve this for x? 3e to the negative 2x power plus 4 equals 10. First thing I'd do is subtract 4 from both sides. That's what they did also. Then I would probably go ahead and divide by 3 on both sides. And that's what they did also. Then I would take the natural log of both sides. Oh, that's what they did also. Similar to what we did in 7-6 when we took the common log of both sides. So what this lets me do is move this negative 2x in front as a coefficient. So I get negative 2x equals the natural log of 2. Where did ln of e go? Right. Shouldn't it be this? Well, if you remember, when I put it in the calculator, the natural log of e, ln of e, is the same as saying log base e of e, which is similar to log base 10 of 10, which is equal to 1. So that's what happened. This is equal to 1. And so negative 2x times 1 is just negative 2x. Then I could go in and divide both sides by negative 2, and I've solved for x. And I could put that in the calculator if I wanted and get the decimal form. But if they don't ask you for the decimal form, then you leave it like that. Similar problem here. Subtract 5 from both sides. 2e to the negative 2x power is equal to 10. Divide both sides by 2. E to the negative 2x is equal to 5. Take the natural log of both sides. So then I get negative 2x, I'm taking a shortcut, times what ends up being natural log of e, or 1, equal to the natural log of 5. I know I skipped a step. Okay, here's what I did. ln of e to the negative 2x equal to ln natural log of 5. I moved the negative 2x out front, negative 2x times natural log of e equals natural log of 5, and then I took and I substituted 1 in the place of natural log of e, and then I ended up there. So then I get negative 2x equal to natural log of 5, divide both sides by negative 2. X would be natural log of 5 divided by negative 2. Put that in the calculator. And hopefully you get negative 0.8047. Let's test it. Let's go back. So we want the natural log of 5 divided by negative 2. So ln right here next to the 4. There's the ln button. Natural log of 5, close my parentheses, divided by negative 2. Negative 0.8047. And so that's another way to verify that I'm right. And it shows you how to do it in your calculator. So what about this? I'm going to solve for x. The natural, 2 times the natural log of 5x is equal to 6. I want to round this to the nearest 10,000ths place. What will we do? Maybe we'll divide both sides by 2. After we divide both sides by 2, then we can translate that back into, take them both to the exponent. Property of equality of exponential functions. So the exponents would be equal. I'm not sure that I like this step. I would prefer that we would write that as something like this. Log base e of 5x equal to 3. And then we could take e to the third equal to 5x. And we would get the same thing. So that x would be e to the third divided by 5, and you can actually put e to the third in your calculator. E is by the divide sign, so second divide, e to the third divided by 2, I believe. Was it 2? No, it was 5. We'll do that again. E to the third divided by 5. 4.0171. 4.0171 is correct. To solve this inequality, similar. We would first write it out, okay, and then we can move. I'm not sure that I like it written that way. I might prefer to take the 2 out front. So we get 2, and then if I write it as a natural log with just as a log base e of 3x plus 1 equal to or greater than 8, then that would mean